Hello everyone, I hope the mic is good, so I hope you have a good lunch. My name is Cristian, and I will talk a bit today about unmatched high availability in the blockchains without having a compromise on performance, either or privacy. So we don't have to choose between privacy and performance. At any point, if you find something which is not making sense, please raise your hands so I can jump with instructions. So biggest threats of Web3. Bear market, obviously, it's not one of them. We have these three huge pains, but not, let's say, the whole space looks at the issues. So we have centralization bias, and we see how it translates, privacy aspects, and also security aspects as well, because they go hand in hand when you talk about privacy and security. Okay, some facts. So on centralization, we already started to see that Web3 infrastructure starts to be centralized, and the issue it's not in cloud providers, but more into the centralized RPCs. And then moving forward, the validator footprint is shrinking. We have some examples with red in the slide. From that moment to decision, DAO included, that make wrong decision or at least compromise and like somehow spots the enemy, which is the centralization. And the last and more recent with the DeFi, which is supposed to be decentralized, but it's not so decentralized. Sorry for the bad news, but for example, DAI is just a nice front end for the USDC. Like if you look on collateral, 80% or 60%, over 60%, it's USDC. So it's not so decentralized as the name might suggest. Okay, more technical data. Nakamoto coefficient, as you may see, does also numbers from last year, but pops out the issues of centralization. And in different networks, maybe they're a bit higher this year, but still far away from what we should see at this moment. Another aspect, especially for developers, it's 90%, over 90% of the Ethereum smart contracts have the same code similarity, at least 50% or 56%, as I suppose in this slide. So I think it's a good reuse of the code that's existing, but also somehow enhances or at least points to the hacks and scams that we've seen, like 2 billion in the first quarter of this year. That's a reason, or at least a direction where this comes from. Okay, and now speaking more about privacy, in order to have a full spectrum of privacy, end-to-end privacy, you need the full spectrum, the full channel of privacy from the user until the blockchain is being, let's say, doing the job. So I splitted the flow into paths, on-chain and off-chain. On-chain, it's obviously zero knowledge, ring signatures, curve pairing, whatever technology you may find it, that hide recipients, amounts, and that kind of stuff. But we still have a missing piece, which is currently developed and already have options, but the flow is from the user, myself, which I'm using a wallet, let's say a game, a DEX, whatever, and I'm sending a transaction from my computer to the node. So the node and the network basically sees everything. So we need to cover both pieces. If you are using, let's say, a normal network provider and you are using an on-chain solution, doesn't matter. So you can map the IP address with the new Ethereum address or Polygon address or whatever. But in fact, if we go deeper, we'll find that the off-chain privacy splits in two. It's the network level privacy, for which we have solutions like the friends from Hopper with mixnets, but there is also application level privacy, which also translates to some, let's say, issues in the space. So it's roughly 1 billion lost in MEV so far, before the merge and after the merge. And basically everyone tells you that you don't need privacy if you don't have to hide, but you still have losses, right? There are multiple types of, let's say, MEV. I will not go in each and every one because we'll end up probably like this. But how to avoid it, right? What's the next step? How we can do something into that direction. And the response lies in privacy. And more specifically, what kind of privacy? The pre-mining transaction privacy, basically for the dev in the room while the transaction is in the mempool. So if you look, or at least some time ago, if you looked on Etherscan, you may see the private transaction label, which shows that the transaction was somehow bypassed the public mempool and reached out directly to a bundle or for the miners. So the transaction is being hidden by the hungry searchers and MVV extractors, and then when it reaches the chain, it's impossible for them to make any changes. Of course, you have to tip the miners, the validators, but at least you have let's say, a governance model about how it works. Okay, what's the state of the art? So for private mempools, Flashbots, Eden, and others on-chain, lots of developments with zero-knowledge proof. It's pretty trending at the moment. On network-level privacy, as innovation, we have the mixnets. And on application-level privacy, we can look forward and see solutions as Suave being developed or others proposals as well. But back to the point of centralization issues. So RPC nodes represents the interface to the Web3. And not only that people, or at least user, expects for RPC to be free, but they expect for us to do something. That's any kind of added value that we can bring to the system with respect to privacy and decentralization. And in fact, we might see that they come kind of hand in hand, because if you have decentralization, your request might end up to a person which might do funky stuff with your data. So you need privacy by default in that. Also, the security measure can be seamlessly implemented at this level, even for non-technical users, right? So you don't have to understand the full crypto space in order to be protected. And also to achieve a true havability via decentralization. Let's look how the current market looks like, or at least the solution that we have. Like centralized managed providers give us some promises that look very in short like this. You have to pay a premium for the high availability. That's their pitch when they give you high numbers in sales. Guaranteed SLA, which means that if you are down, you get a refund. So it's not basically an SLA, it's a kind of an SLA. And continuing believe us as approach. Let's see the numbers. So on the left side, there is the Arbitrum airdrop, 23 March. And as you may see, when things go wrong, you don't have any more what you paid for. So a reality check is that you have a premium price paid for, but when you need it, the high availability, it's no longer then. You get a refund. That's cool. And not speaking about privacy, because you are decentralization, so obviously it's not even the case to have any kind of privacy at that level. And basically, it's everyone trying to move through the same door, and the RPC become overloaded. So if you don't have a decentralized approach to this, imagine how the Ethereum network never went down because it's decentralized. So it's always a node right there to take the system and have the incentives to put others to work. That's why the Ethereum door, let's say, it's so big, because they have this approach of decentralization. And the problem, it's not actually only from this year. If we look back in 2017, 18, and so on, we see the same issue, right? Which is basically translates that the door, it's too small, or it's a single door to access. Our vision, it's like the RPS, it's the North Star, the higher, the better, in order to have a complete end-to-end privacy without compromising the performance. And we need measures to have a built-in redundancy, which is provable, available, without any promises, and also the incentivization model and economic security in order for those nodes to work as supposed to be. So if I join with a node, or any of you join with a node, we need to provide reliant services to the network. So you need an incentivization model for those to run good nodes, or at least performant nodes. The result is that in the end, you may end up having a clean system without downtime when the times come, and it's basically you need it. Thanks for your attention. If you have any questions, happy to answer them.
Hey, what do you think about encrypted mempools, especially using VDFs and some ASIC device?
So encrypted mempools are a way of going through, but they have a flaw at the moment, actually two flaws. One is performance, because you have a bunch of technologies like homomorphic encryption, SMPC, maybe differential privacy, which is not quite the full privacy that you want to have, but SMPC and fully homomorphic encryption have some drawbacks in terms of performance. So while you are doing the computing over encrypted data, there's a huge downtime, or at least you lose some time. That's one thing. You can cover it in some places, but because you don't have the full spectrum of viewing what it happens, you will leave, as an MEV, at least in this space, you will leave cache on the table because you're not seeing all the options and optimizing your, let's say, strategy, as opposed, let's say, the searchers that see the full spectrum of data. So basically, we will have to make a compromise, at least with the technology that we have so far, between what money you leave on table and how much protection do we have using those technologies. Thanks for the question. Anyone else? Cool, thanks.